Unison is a statically typed functional programming language that treats code as content addressable and immutable, and that forms the basis for it to robustly support dynamic code deployment, allowing a single program to describe an entire elastic distributed system.
Yeah, I think that these are really, really powerful concepts, and actually what I would encourage Unison developers to do is to actually see if this can be applied outside of just this one language.
Hi, this is Will.
And this is Sri.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it, an optimistic look at the road ahead. Hey, how's it going, Sri?
Pretty good, pretty good. I'm excited for another week, a new topic, and a new drink.
New week, new topic, new drink. So what are you drinking?
I am drinking this thing, just found it today. It is Ritual Zero Proof Whiskey Alternative. It is a alcohol-free whiskey-flavored beverage that you can put in a mixed drink. So I am drinking a whiskey and Coke.
Does it taste like whiskey at all?
It does, actually. I had a little sip beforehand, and yeah, it's a passable alternative in a mixed drink. It's pretty disgusting if you drink it straight.
Which is exactly what you're doing right now, right?
Yeah.
So does it warm you up when you drink it?
No, it just sort of tastes smoky.
So I am doing something pretty plain this time. It's just honest, organic, just green tea.
Nice.
Just. Somehow just is in quotes. But yeah, I don't know. Honest is, I guess by now it's a pretty popular brand. So no surprises there.
Coming back from the depths of hipsterdom to slightly, mainstream brands.
Yeah, I don't know why I picked this up. Probably because it says unsweetened. So just for the sake of putting these things where it's actually a whole bunch of sugar. So I don't know. So anyways, what are we talking about this week? I guess that's your question for me. Go for it.
Indeed. Well, what are we talking about this week, Will?
We're talking about the Unison programming language. Have you heard about Unison before?
I have heard of it really early on in its development, but I was surprised to see how far it's come along.
Yeah, well, Unison is a statically typed functional programming language that treats code as content addressable and immutable, and that forms the basis for it to robustly support dynamic code deployment, allowing a single program to describe an entire elastic distributed system. So did that make sense? Was that too many words all in one sentence?
That's a lot of big fancy words and a pretty big promise, so maybe we can unpack that.
Right. And so I guess the core idea here is that code is content addressable. So for those of our regular listeners here, you'll remember from the IPFS episode that content can be hashed and then be referred to by that hash. And so if you try to find data or content, files, images, text by a hash of the content, and that's how you find it, then that's content addressable. And so here, normally when we write code, it's on our hard drive as a collection of files, and we just kind of dump into it. But here in Unison, they treat functions as content addressable, which means that every time you write a function, you effectively commit it into Unison itself, and then therefore it becomes immutable. You can never change that particular version of the function ever again. And so if you want to quote unquote update it, you actually just append a new version of it. And so that means that you have a series of functions with different versions all collected in the programming language itself and not in the version control.
Yeah, the way that I would describe it in looking at a few of the demos that I found online is that Unison almost comes with Git-like repository, but rather than working at the level of files and hashing the contents of those files, it actually hashes and caches individual functions. And so there are cool demos where you can sort of update a function, you can rename a function and point basically what's a new tag or a new name to a pre-existing hash, as well as sort of allowing sort of these like fork and merge operations so that people can decide which version of a particular function that they want to use.
Yeah, hash and cache should probably be the name of a drink or band, I guess.
Yeah.
So like being able to, or treating code as content addressable turns out to have a lot of different implications that I'm wondering like why I didn't think of this. Like it seems so obvious in retrospect, but yeah, like those are some things that we'll go over. And so that's the first part of that like glom of words in the beginning. But the second part of that intro sentence refers to Unison's attempt at treating the programming language as something to program a system of computers, a collection of computers, because before, the programming languages are all concerned with trying to make a computer on a single machine with a single OS process to do its bidding. But then since then, we've had multi-threaded, multi-core, and now effectively distributed systems for our large-scale web properties, and we're still using languages that assume a single OS, so we have to invent all this stuff around it. And so Unison wants its programming language to take multiple computers in a distributed fashion completely into its purview. And so that's the other thing that's interesting about this.
Yeah, in the IPFS episode, one of the things that came out of our discussion was the realization that when you have this core idea of content addressability, what it ultimately does is alleviates the burden of maintaining a lot of infrastructure for, in the case of IPFS, the storage infrastructure. And so I'm curious if what makes Unison good at distributed systems is something similar about content addressability, where you can reuse parts of the code base, or not have to specify at such low levels how you want your code to run.
Yeah, I think that's it. And definitely that's something we'll get to later in this episode. So I guess first things first, earlier I mentioned that when you are able to treat code as content addressable and immutable, like all the functions are hashed, there's a whole bunch of implications that come out of this. And so we'll go through some of them real quick. All right, so going back to one of the things that come out of having code as content addressable and mutable is that renames are fast. And so what this means is that normally when you have code that are just a bunch of text files and you need to refactor and rename them, you'd have to do search and replace across the entire code base. But here, if the code is content addressable, names are really just pointers to that hash that represents that function. And so when you rename a function, you're just changing where that name points to, like which hash that points to. And so that means that that operation is really fast.
Yeah, so we'll try to avoid getting into the nitty-gritty, but I think this is a key point to understand, is that in the compiled version of Unison function, rather than referring to the functions that it depends on by a name, it actually depends on them by their hash. And so that hash doesn't change no matter what you call it. And so you can basically apply different labels to it, and it's fine. And so renaming is just saying this hash is known by a different label now, rather than having to go and change all the functions that actually refer to it.
Right. And so if this is the only benefit that you get, then you might as well just go do something else. But it turns out there's other things that comes out as a result. So for one is that builds only happen once. Like you only have to compile a function and all its dependencies just once, and then it's forever cached, because all the functions are immutable, and if it's immutable, you only have to build it once and it would never change, right? And then that also means that if you ship that code somewhere else, nobody else needs to build it ever again either.
Yeah, that makes sense. And actually the nice thing is that if you ship that code over once, if you ship a function over once, and you don't have to worry about sort of whether the remote computer that you've sent the function over to has the same exact definition of the functions that you depend on. So you can avoid worrying about, well, I have this thing that works on this version of my runtime, and the remote computer is using a slightly different runtime that has a slightly different definition of these standard library functions or something, because you don't have that issue anymore, because the functions are known by their content rather than by names.
Yeah, and I was thinking of it more as a library, but you were talking about it more as a distributed system, and I think it's the same thing with two different intents, but you get the same effect, right?
Yep.
And also, since the functions are append only, so you can never destroy a version, you only get new versions on top. That also means that cache invalidation never needs to happen. And so what's the quote about hard things in computer science? There's only two things that are hard in computer science: naming things, cache invalidation, and off by one errors. I think that's a full quote.
Yep.
and so that's kind of a nice thing that comes out of it. And then lastly, related to builds, that also means that for incremental compilation, it also goes really fast, because everything's cached and immutable. You only ever need to do it once, and so it should go by pretty quickly. I find that one of the comments about Rust is that its compiler is comparatively slow, but that's because it has to do lots and lots of things, because you're effectively shifting the burden of what normally happens in runtime to compile time, so that's not surprising.
Interesting. Yeah. I mean, those are a lot of really powerful benefits. I think any one of those would be interesting, but maybe a marginal improvement on the current state of the art. But having all of them together seems like it is a kind of killer set of features.
But wait, there's more. So,
or as Steve Jobs would say, one more thing.
Right, one more thing. Well, so this also applies to dependency conflicts that can happen, because in various package managers, you could have this what's called the diamond problem, in which your function depends on two different libraries, and those two libraries might depend on the same library, but it turns out that they need two different versions. And so various package managers in different languages have solved this problem just by downloading different versions and being okay with it if they had the foresight to design it that way. But here, it just, once again, goes away, because entirely different versions just have entirely different hashes. And so it's completely okay that the two libraries that you use are depending on technically the same library, but two different versions. And so, like, they would just download different hashes or different versions, and you'd be none the wiser and go about your day.
Yeah, that's actually a very, very powerful idea. It's not just a bullet point in this list of features. Recently on Hacker News, there was a story from some startup that was using a MongoDB ORM for Ruby, and they ran into this issue exactly, where the package for that ORM package, they updated the definition or the functionality of one of the really core functions that you use to build queries, and that completely changed the logic of how they bill customers, and they ended up billing a ton of customers that they shouldn't have billed. And so,
ouch.
Yeah, so like this is a problem with package management, and generally, if you don't think about it this way, but package managers and package versioning is a kind of giant distributed coordination problem, and so if you're able to basically pin the version of a package that you can use, or more specifically with Unison, pin the particular functions that you use, then you don't have this problem where things change underneath you, and then the logic of your entire program changes.
Yeah, and I guess, like, to the theme of Unison, there's all this stuff around code that as working programmers we need to learn, and so it's just trying to use this one tool to expand the scope of that so that you just don't have to worry about this sort of crap. Yeah.
So that's pretty cool.
Yeah, and also you would think that it might pull down more than you need, but like if those two versions of the library that your libraries are using, they probably share code, and so structural sharing is a thing here. If you're familiar with immutable data structures, it's effectively where the roots are different, but if they have common elements, you'll just reuse those. Did that make sense?
Yeah, I mean, basically, if you structure or you view your entire code base as a dependency graph, then when you update a subset of that graph, or whether that's you're changing your own function or you're updating a package that you rely on, then for the most part, the structure of that dependency graph is the same except for a few deltas, and so you don't have to rebuild everything. You sort of just update the deltas.
Yeah, and conceptually, if this is how Git works underneath as well. Like conceptually, semantically, like we think of every commit as a whole different version of your source tree, but as it's implemented, it doesn't save a completely new version. It just reuses the hashes of files you haven't touched and just points to it with the new commit. That's exactly the same idea. And the last thing that's an implication of the content addressable code is you can have multiple versions of your code that serialize and deserialize data structures. I thought this was kind of a subtle point, but it was also pretty interesting. And I could see that when I was looking at event sourcing as an architecture, one of the problems that came up with event sourcing is like, how do you deal with different versions of the data that you wrote onto that bus? Like every time people like talk about Kafka and stuff like that, they ignore like versioning problems. They just feel like, oh, okay, like we'll just throw this stuff on the bus and then people can just look at it whenever, and we'll store like, I don't know, a month or two of it. But the thing is, code gets updated all the time. And so effectively you're pushing this problem back up to the application layer. And so, so here in Unison, like if you are serializing some data structure, version 1 and then you update your code to serialize version 2, you can still keep version 1 around to read in data that was written in version 1. And so I thought that was pretty neat. And so you don't have to manage this by yourself. Like you don't have to write code in which you just have different versions of the same function and have enough discipline on the team not to touch anything that you've already written, right?
Yeah.
I thought that part was pretty neat.
Yeah, so I work at a giant company that stores a lot of data, and one of the problems is that when you serialize data structures and write them to disk, your data at rest has to be forever forward and backward compatible with every anticipated version of your code base. And this is incredibly hard at a huge company where the code base is changing literally every second. And so there are a lot of practices around how do you update fields, how do you add fields, how do you deprecate fields in this binary data storage format. And so, I mean, it sounds like having a self-describing data structure allows you to not have to worry about whether your data at rest will be compatible with your code base going forward.
Yeah, and so that's kind of a nice convenience for people that, I guess, expose themselves to that sort of problem. And so I guess at larger companies, you're okay with burning people's time because why else did you hire them, I guess?
Yeah, well, so, I mean, I think that it's interesting because a lot of the time you don't realize the scale at which you are working until it's too late. And so what I mean by this is that...
It sounds like a cruel joke.
Yeah, exactly. No, it's one of the issues with anything that gets really popular, whether that's a package manager or company or whatever it is that complexity increases quadratically in the size of the number of components, whether that's the number of people working on a code base, the number of programs that are dependent on packages, et cetera, et cetera. And so people don't anticipate this. And so as your system scales, it scales faster than you think it would. Mm-hmm. And really, really quickly, you run into classes of problems that didn't exist just a little earlier when the problem was more tractable. And so it sounds like Unison basically says, don't worry about that. Like, you can keep it simple to start with, and it will stay simple as your system increases, and not have to deal with this quadratic complexity of either software engineering discipline or build complexity or package versioning, et cetera, et cetera.
Yeah, it's hard to know where that balance is, right? There's a reason why Yagni is a thing, right? You're not going to need it because there are people that fall on the complete opposite side of the spectrum that try to anticipate every single thing that their code base has to scale to, and you end up building a lot of things you don't need, or even worse, the wrong abstraction, and it hinders everybody else even more. And so, yeah, definitely this helps, I would say helps alleviate this particular class of problems. And so all of these things are things that fall out of just having code that is content addressable. And like I said, I wish I thought of it. Did you feel like it was really obvious once you read it? And do you wonder why now and why we didn't think about it before?
Yeah, I do wonder that. It's not entirely obvious if you went up to me and said, I'm making a programming language that has content and addressable functions, that all of these benefits would immediately fall out of it. It makes sense now reading it in retrospect, but prospectively, if you came up to me and said, hey, I'm working on a cool new programming language and it's going to be based on this one principle, I would be like, why that one principle? And so, yeah, it's completely non-obvious, actually.
So, but why is it non-obvious? That's the thing. Because we've had cryptography for a while, and we've applied it to data. And there's the saying that code is data and data is code. So, is it just momentum from language and compilers that we read files?
I think it's not that the idea of content addressability, I would argue it's not even to do with cryptography. It's the notion of identity and the fact that something can have an identity independent of its name.
Yeah.
And when you conflate the difference between identity and name, this is when you run into all kinds of problems, not just at all levels of abstraction, from the interpreter level all the way up to the sort of societal level of how do programmers coordinate on a single code base.
Yeah.
And so I think if you solve this fundamental sort of class of error, you end up having really nice effects all throughout the stack.
It's strange because like I never thought about this at all until I read Rich Hickey when he wrote about this issue with closure. I think it's something like identity and value. They're actually two separate things, and most languages and people conflate the two, but it's actually not. And so like for numbers, we have very good ideas of like 42 will always be 42. And I guess my favorite analogy is that once George W. Bush was president, he's always going to be a president or has been a president. You don't like overwrite him with Barack Obama.
Hopefully he will not always be a president.
Well,
yes,
always have
he will
been.
Always have been.
Right.
Yes.
He will always have been a president. And so, like it's. I guess people aren't used to being pedantic the way that you have to be when you're a programmer, I guess. And so I think the functional people have really gotten it right in this sense, and I can only see that this sort of idea will keep fanning out and be more pervasive throughout the programming world as we move forward.
Yeah, totally. And I think one thing that is to Unison's credit is that the idea of identity versus value is prevalent in many functional programming languages, like Clojure especially.
Right.
But one of the new things about Unison is that it sort of turns that idea inward into the structure and the interpretation of the language itself.
Yeah.
And so you can have functional programming languages that have immutable values that might memoize things, et cetera, et cetera. But this is the first language that I've seen that actually just takes that and applies it to itself.
I guess if it was homo-iconic, it could use all the functions on itself, but it doesn't. I think it's based on Haskell, so the syntax. Anyway,
that would be cool. Yeah.
So anyways, that's kind of all the things that come out of it being content addressable. But in actuality, there's also a couple other things that it has that have nothing to do with content addressable. And so we're going to say there's yet one more thing for the rest of this episode, I guess. So one thing that we want to move on to is how refactoring is a controlled experience. I mean, like I've been mostly relatively small teams, but even in small teams, like refactoring is just a pain in the ass. I think partially because in a small team, in a startup, you're looking to go fast rather than correct. And for those of you that don't know about startup culture, I guess this might scare you depending on like what kind of product you use from them. But I mean, there's good economic reasons for that, right? If you don't get it out there into hands of users, you might be building the wrong thing. And so that's a whole nother podcast. But refactoring is often a pain in the ass. And in functional programming languages, refactoring is less scary because in imperative programming, like if you even have if you have no tests, I mean, it's a scary proposition. If you have tests, then you know that you're at least covered for the things that you tested for. In functional programming, there's less fear in refactoring because not only do you have tests, but you have the type checker to help you out because when you change something, the type problems will cascade and you'll get a whole bunch of errors. But once you fix the errors, you're pretty much guaranteed to have it compile. Of course, you might still have logic errors. You can't, like the type checker won't protect you against that, but you won't be running something in production that gives you runtime errors. But that said, for me, it's really frustrating to write something in a pure functional programming language in it and refactor and then be faced with this long list of 100 type errors that you just have to like bang out.
Yeah.
And so in Unison, apparently they've tried to increase the user experience for that. And so their philosophy there is that the error should read like another developer is explaining the problem to you, which I think is really nice because Haskell's errors are terrible. And Elm is way better, but sometimes I'm like, oh, it's confused. Like the type thing is shifted and confused. And so it uses two things, which is bidirectional type checking and type error provenance to help with that. And so I hear that you know a little bit about bidirectional type checking. Yes?
I'll take a stab at it. Yeah, I mean, it seems like it's a type of type checking that works in sort of two passes where
that's bidirectional.
That's bidirectional. Right. So the two passes are it goes through the code base and actually infers the implicit types and the constraints on the types based on how variables are used. Mm-hmm. And then it does another pass where it says, are all of the types being used in the way that you expect? And so there's sort of this inference where it sees how things are used and that helps it check on the forward pass rather than just sort of doing the one forward pass and saying, oh, actually this thing doesn't compile and I can't tell you why. it says this thing doesn't compile, and I can tell you why, because this variable that you said is a string is being used improperly or something like that.
I see. Yeah, the kind of type errors I find most insidious is like you might reduce or increase the number of arguments, and now like the types are all wrong because all the arguments are shifted, but like the errors don't really tell you that. It's a little incomprehensible, especially if your types get more complicated. Yeah, so I think that's really nice. I like to experience it, but I don't really have anything to build in Unison at the moment. So, but I should play. I'm going to play around with it more to experience the feel. And then I think lastly, like going through this list, like blowing through it, I think one of the is not the last thing. It's the second to last thing because we have yet one more thing. So Unison is one of the few programming languages that have algebraic effects built in, but they call them abilities. Do you know what algebraic effects are?
A little bit. I've seen them around, but I don't know formally what they are.
It's basically a building block for control flow. Way back in the day, people did control flow with if then else statements and go to statements, right?
Mm-hmm.
And then Dijkstra came out with this paper that said go to is considered harmful because it turns out that most types of control flow that people were doing, you basically do them in a block style where you have a scope and you have while loops and if then statements with blocks and that sort of thing, like things that programmers take for granted today. Like the fact that we have these curly braces with blocks, like that came out of the idea that go-tos make for spaghetti code that is completely incomprehensible, right?
Yeah.
And so having had that for a long time, you might think that that's the only way to do control flow, but in fact it's not. We have something that's not, and it's the exceptions. When there is an error, you can throw an exception, and so that breaks control flow, in which whatever try block that you have, if an error is thrown in there, it jumps out and looks for a catch block. If it's not in that function, then it keeps bubbling up until you see a handler for that error. And so mechanically, algebraic effects are similar, in which you're trying to perform a side effect. And do I have to explain what side effects are?
No, I think we've sure.
Real quick, in pure functional languages, the output of every pure function is only dependent on the inputs. But in imperative languages, that's not the case, because inside some method, it could launch a rocket or feed your dog or whatever it is, and then return something, right? And so those are called side effects. It happens to the side. It's an effect. And so typically writing to console or writing to disk or communicating with a network are considered side effects. And so algebraic effects, one of the main things it can do is allow you to deal with side effects in a pure way. So typically in pure functional programming languages, people have leveraged monads to do this, to deal with side effects. But here, algebraic effects are another way to deal with side effects. And mechanically, you would ask, perform, fetch something from the network, right? Yeah. And so in a programming language like Haskell, then you don't write the handler because the handling of the fetching the data is done by the runtime. It decides when to execute that, and then it'll return it back there. But with algebraic effects, you write the handler also. So just like a try-catch block, you try or perform, you ask the system to perform the side effect, and then either in the same function or somewhere up the stack in the function, there's a handler that handles that side effect. And so it'll execute that handler and then jump back to where you performed the asking of the side effect to be performed and return that result and then resume from there. Does that make sense?
Yeah, it does. And that seems interesting because you could write new handlers based on new environments or new types of side effects that you want to add to the system. So that sounds pretty powerful. Yeah,
it is actually, because it turns out that with algebraic effects, you can use it to create other types of control flow that have only typically been implemented in the language itself. So other things like coroutines can be implemented with algebraic effects. You can write your own try-catch exception, like exception handling mechanism with algebraic effects. So that no longer has to be built into the language itself.
That's pretty cool. And I think that in looking at Unison, they also implement their distributed computing using algebraic effects as well.
Oh, really? Okay, yeah. Apparently it's a powerful thing. And so the effects, it refers to side effects. So normally for other pure functional languages, in order to deal with side effects, you wrap it up in a monad. And so the type of the computation gets wrapped up in the monad itself. And so then you get these like two colors in your code. Have you read like what color is your function? Yeah. Show notes. We'll put that in the show notes. And so you kind of have to end up like going back and forth. Here, algebraic effects don't have that two-color problem in your code base. The side effect types are in the type of the function, but it's separated from the types of the inputs and outputs of the computation.
Yeah, I think that makes a lot of sense. And yeah, going back to the idea that the remote computing or distributed computing is implemented in Unison using side effects, basically what that means is that you can take an arbitrary function and say, now this is a remote function, because you don't have to make all of the types within that function aware that they are being run in this side effecty way, specifically the side effect being sent over a network and executed on a different computer.
Yeah, and that leads into our next part, in which it's supposed to subsume other computers on a network into its purview just in the programming language itself. Because what Unison, as its demo, does is it implements a search engine in 15 lines, or of course, like the core of it is there. There's all this other stuff around it, but that's less than what you would typically have to do for like a distributed system. And so there are keywords and abilities for you to, like you said, send functions to remote nodes to be executed on there. So instead of setting up servers or services on Kubernetes that does a specific thing, you can just stand up nodes that don't have any code in them in Unison and then just ship the functions to them. And the reason why you can ship the function to them, because they're immutable and content addressable. So like the remote node just has to ask itself, do I have a hash of this function? If I don't, send it to me. If I do, I don't need you. Like it's already cached and just execute it. And so that kind of simplifies a lot of things that you would have to do with distributed systems in order to code up a system that does, say, a search engine.
Yeah, it's kind of like taking Kubernetes to its logical end, because Kubernetes says we are going to package up a program and all of its dependencies and send them over to undifferentiated, servers that will execute these programs. And with Unison, you can sort of take that even down to an even more granular level of a function and say, treat this function as a package or container that I can send around to sort of agnostic servers, and they will, fetch all the things that they need in order to make it run, and they'll just run it.
Right. And so some people have asked, like, what is the difference between like Unison and, say, Erlang or Elixir? And the answer in a talk apparently was that Erlang and Elixir send messages around in the distributed system, and they wanted to like lift it one level higher so that you operate on the level of functions rather than passing messages around. And so I don't know, will that work out? I'm not sure if that introduces new kinds of complexity, because I haven't worked in it, but supposedly, I mean, it's nice to be able to program the entire system within the same language and be able to pass functions around, because you can say, I want it executed on this set of nodes rather than having to say that particular one.
Interesting. I mean, the world is kind of moving this way with the so-called serverless movement, where you think of programming as sending functions around to whatever service, like Cloudflare workers or Amazon Lambda or whatever, and they'll just like run these functions. It's not quite like that, because you have to do some amount of setup and things where you upload your code to them. But it sounds like with Unison, you can sort of reach that ideal of having this cloud, and you say, I run this function with these arguments, and it will just figure out, okay, I have a copy of this function, I'm going to execute it, or I don't have a copy of this function, let me download it from the global universe of content addressed functions and download that and then execute it. And you don't need to sort of have all this like set up beforehand in order to just like run a function.
Yeah. I mean, in our pre-show coordination, I was joking that this would be like a proto-Pied Piper, and I guess that's the dream, right? Where you would just have a fleet of servers somewhere, and you'd be able to ship code to it and not worry about like where they are, exactly where they execute. But I think the caveat here is that it's not like a blockchain. It's like you're in control of these servers. It's not like an adversarial environment.
Mm-hmm. Yeah.
So I guess that's kind of try to power through it. for like all the implications of Unison, and so it's a little heady. Are you reeling from it, or like are these things like not surprising?
I think that I went into researching Unison, thinking that the main benefits that I would see are something to do with its, type checking, something to do with the, remote processing and distributed systems aspect of it. But really, the huge advantages that I see as a humble working programmer is the whole coordination problems that it solves, the human side of software engineering that it solves. Every day you read about some horrors of package management, some horrors of, there's so many debates about like, should we keep our code in a mono repo versus having, lots of hundreds of tiny Git repos. And they all sort of come back to the same thing, which is like, how can we make sure that things don't go out of sync? You change one thing, how will it propagate across all of the different, tiny repos? If we have mono repo, then how do we make sure that you're not like constantly churning through your code and blowing away all your builds or whatever? Like all of these things, people will debate hours and hours endlessly. The Hacker News comment chains go so deep because people care about these things. They have strong opinions about these things. And, reading about Unison is just like, don't worry, none of this matters. Like, none of these are problems at all. And I'm like, this is crazy. Like, you'd think that these are the fundamental, hard problems of software engineering. And then this language is saying, no, it's not.
Yeah, it makes me wonder, like, well, we do have the... In software and in computing, we have the notion that you want something like Unix, in which you have a tool that is sharp, and so it does one thing well, and then the second thing is you have to be able to compose them. And so I think we probably followed the first piece of advice because we have all sorts of specialized tools for it, but maybe not the second. I mean, like, we do have like version control with Git, but it's not a part of our programming environment. We have databases, but it's not part of our programming environment. And maybe that should be rethought. Like, the only programming language I can think of that has a database built into it is Smalltalk, which we covered, and it has an environment which lets it do all sorts of things. And so here, Unison similarly has a quote-unquote database. I don't think it's a relational database, but
yeah,
has a database. And it thinks of code in a very unique way, and you can see it as text if you want, but I don't think it's stored necessarily as text. Like, it's I want to venture to say it's like a Merkle tree of some sort, but that's just a guess on my part.
Yeah, I see. I mean, it does remind me a lot about Smalltalk, because in the Smalltalk episode, just to recap, the idea of Smalltalk is that your program is not a series of text files that then you feed into something and it executes it. It is, your program is, the logic, all of the definitions, all of your objects running in a sort of environment. And so it takes on that approach of defining what a program is. In Unison, it doesn't quite go that far, because it doesn't sort of say your whole runtime and your whole memory is part of your program, but it does say that your program is not just the text files and the names that you give it. Your program is sort of your dependency graph and these functions, and these functions have an identity independent of, or have a value independent of what you call them. And so I think that these are both sort of corrections of this very Unixy view of compilation, which is that you have, flat files which you feed into a compiler, which outputs, build objects, which then you pass into a linker. Maybe that's how it was needed back in those days because of the limitations that they had, but that is not the only way to think about how a programming language can be built, or how programs can be built.
Yeah. I liked how you tied it back, because I guess I want to emphasize that it would have been fine if like all these tools that you have outside the programming language also composed, but a lot of times they just don't. Like, we have like this menagerie of stuff like outside of the program application itself, like from the different databases you use to like the container Docker and like the orchestration stuff like Kubernetes, and like if you have large like deploys, it's Zookeeper, and then like monitoring with Prometheus, and there's just all sorts of stuff. And like a lot of times, like configuring that stuff, like I'm loath to learn it because it's just arbitrary settings and configuration. It's not hardcore. It's not like core concepts that are transferable. Like just because you learned like AWS, like those configurations and the concepts that you have there does not transfer to GCP or like Azure, right? Like those, it's just arbitrary things that you have to learn. Like none of these things like have core concepts that are in common that compose with each other. And so like the Unix, so I think this is emphasizing this because we're not saying that the Unix philosophy is bad. We're saying it's incomplete. Like we build a lot of sharp tools that do one specialized thing well, but they don't compose. And so we get like these issues where, okay, version control can version your files, but like that, those properties of uniqueness don't transfer out to your like cluster, like Kubernetes cluster, right? Like all of that evaporates. And so here, like Unison brings it all under one roof so that you could do that. And so maybe another alternative is if there are core principles for these properties that can be used and transferred across tools, that might be like a different approach as well. Like instead of like putting it all together.
Yeah, definitely. Yeah, I totally agree with you. I think that, you know, the sort of the craft of building software, the trade of building software has really changed since back in the day when you had a single machine and you know, you run whatever GCC or whatever on some code base, a C code base. Now, you know, it's a group environment where you have multiple people, many people working on a single code base. We have things like code review, which I'm not sure if they had back in those days. So
I don't know.
Yeah. So
maybe like I think NASA has code review, but like they're operating on a completely different like
well, they really need it. Yeah, but you know, if you think about how code review tools work today, they don't know anything about the structure of your program or, you know, that you're changing a function. They just sort of treat everything as like text. And, you know, a code review is basically, I'm sending you a text diff, and it's up to you to see like, okay, how does this actually, you know, what does this diff actually mean in the context of the whole code base, right? And so I think that it's possible if you have a very tight definition or a program that has a very kind of crisp definition of how things work, where you could build code review tools that are aware of, you know, the fact that, oh, this is a function that's changing, rather than, oh, this is just a random text file that you're you know, patching a text diff to. And similarly, you can have, you know, other deployment tools also more aware of the you know core primitives of the language, rather than just sort of treating everything as like a sort of blob.
Yeah, and the reason why it's text is because text is portable, right? I can imagine building systems that are sending binary files around as code, and then that would also be an issue. But I get what you're saying in that all these the properties I was mentioning earlier, they just get lost once you write them back into a textual representation, and so you can't leverage any of that. And I guess maybe that's also the fault of the language writers and compilers, because they don't think that their interpreters or compilers could be used for anything other than code execution.
Yeah.
I wonder if like having it be more deconstructed so that tool writers like IDE for syntax highlighting or, I don't know, code reviews could be able to leverage those as well.
Yeah, I mean, I think that, you know, just going back to Smalltalk and reiterating this, in Smalltalk, I watched a couple of videos where code review in Smalltalk is a very different experience, because when you're changing the definition of a function or a method of an object or whatever, the person who's reviewing the code is able to basically bring up your environment and see sort of the effects of that thing, and actually like query like, okay, if we make this change, how is it going to, you know, affect all the running system?
That's really interesting, because like normally when you do code review, you have to like figure out what's going on. You know, a lot of times I feel like maybe I'm just a bad programmer because like I can't follow what's going on. But like sometimes I've come to the conclusion that no, this person that's writing it is just not clear in what they're doing. And so so like being able to have a code review tool that actually has the executing environment, it's basically like using a debugger as the code review tool. So the debugger is not a tool to find bugs, but a tool for understanding.
Mm-hmm. Yeah, exactly. So that's a Smalltalk way of doing things. And I think Unison, you know, doesn't go quite that far, but I imagine that if you have a code review tool that is aware of Unison, you know, you can do other interesting things, because that code review tool will know that, oh, these are not just text files that are changing, these are these functions that are changing, and you can maybe say what would be the effects of applying this function change and then updating all of its dependents versus not. You can sort of, or you can say, well, okay, if we apply this change only over here and not over here, what are the sort of effects? And so you can actually, reason about the dependency structure of your code base rather than just looking at the file and saying, okay, does this look okay to me based on the textual representation?
Yeah. At best, you can kind of just say like, yeah, I guess this makes sense. I mean, or like, I guess you can't, unless you know your code base really well, I guess you can't say this is definitively good. You, at best, like if you're reviewing stuff, and especially if the entire team's trying to go fast, you can just say, well, it doesn't look like there's anything obviously wrong about it, so go ahead and ship it. I guess we'll discover those bugs in runtime. So
yeah, exactly. Actually, there was another thing that came up in terms of how Unison could be interesting in the context of a large system that's being used in production. So
what is that?
If you work on a code base or a system that is in active use, then as it gets more and more users and more and more functionality baked into it, you have to add new features very incrementally based on feature flags. So you sort of gate this new change on these feature flags, because what you don't want to do is just go into a function willy-nilly, change all of the logic there, and then like break prod, right? And so what you do is you gate things by feature flags, and you say, okay, if the feature flag is off, then you go through the old code path, and then if it's on, then you go through the new code path. And this is actually a huge pain. Like for me, I hate gating things by feature flags because it's really hard to look at the code and understand what it does anymore, because now you have to imagine both the two things, and then imagine you have that feature flag not just in one function but all strung throughout your code base. Then you have to reason about all the different ways that it could happen. And so
it's like having preprocessors in your code everywhere. Like for those of you that write in C, having the preprocessor macros and have to reason about that while you have that visual noise all around your code base.
Yeah, exactly. Visual noise. That's a great way to put it. Yeah, and so I think that I haven't seen this mentioned in the Unison docs or anything, but I can imagine that with this content addressable function idea, you can be empowered to create a entirely new version of a set of functions, or a single function or a set of functions, and say this is the new code path. And then you can just commit that, and you don't have to worry about breaking prod, because prod is running functions that reference the old hashes, right? And so they're running the code that's already tested. And then if you want, you can run a different fleet of servers, or a testing server, or staging environment, or whatever that is pointing to the new thing, and then you can verify it there, and then you can update the running server. You don't have to maintain all of these like random if statements littered throughout your code base. You can just straight up have two versions of the same function.
Yeah, and the update is just changing the name because everything's a value, so it should be pretty fast. Because like I don't know, like deploying Docker containers to Kubernetes sometimes takes minutes, on the order of minutes, presumably because you're shipping around gigabytes of data, right? I haven't looked. I don't know exactly why. That's pretty interesting. And like I mentioned before, that probably would be a boon for systems doing event sourcing for that very reason. Because I guess as it ties in to what we were talking about before, like the properties of your version control just evaporate once you're outside the purview of the version control. But here, like for feature flags, you effectively are doing the version control's job in the application layer. Right. And so we don't want that. We want, it'd be great if like version control's properties could be percolated up to the application level, but we just don't have that. And so I guess Unison bring everything under one roof. It allows you to do something like that. That's interesting.
Yeah, definitely. So, I mean, and again, you don't realize that feature flags are such a pain until you have lots of them. Right, one feature flag is fine. 10 feature flags is really, really hard to reason about, and then you have this whole,
because it's not like they're mutually exclusive. Like you might have any combinations of them on and off at any particular time, right?
Yeah,
and exactly. I imagine like people don't have the discipline to remove them after they're done either.
No, it is. On my team, we have every quarter we just have a cleanup week, and the cleanup week is you don't add any more new stuff to the thing. Go back and like get rid of your feature flags and all these like little things that you've littered throughout the code base.
Yeah, and you're way less motivated to clean stuff up when you don't have like something to implement either. You're like, now that it's deployed, this is somebody else's problem.
No, yeah, exactly. And so, and 1 week a quarter is actually not a trivial amount of time to delay, new work at your company, right? And so that's a significant tax on developer productivity that you can just like get rid of. Yeah, using Unison.
That's pretty interesting. Yeah. I haven't had to do a lot of feature flag stuff, but I can imagine. Huh. Yeah. And for me, I think the thing that kind of caught my attention was the idea of shipping around functions as values, but not necessarily as a way to distribute running code in production, but as a way to distribute libraries. And so if it's immutable, you can store that library on IPFS. So IPFS, you don't have to pay the entire cost for your package management infrastructure. And so that means that Unison should be able to have relatively low costs for hosting their package manager on IPFS. They just have to pin that stuff is one.
Yeah, and then, that's pretty interesting.
And then two, if there was a way to negotiate which package makes more sense for this particular core feature, say, I don't know, a parser combinator or something like that, then you would be able to... I guess what I'm saying is like you'd be able to agree on a global code base for the library of things that you can use in Unison rather than like a menagerie of different options. And so when something is new that's coming on, say like, I don't know, in the beginning people write all sorts of HTTP request libraries, but then as people figure out like which one makes sense, you would converge on the one that you want to use. But if people like a previous one, they just stick with it. There's no reason for them to upgrade because everything's immutable. I think on the downside, that might kind of suck because you have to support every version if you care about that. But maybe you just say, oh, we support the last 5 versions, but if you're keeping an older one, you're on your own.
Yeah, exactly. Or, in IPFS, if you really care about a file and you don't want it to get purged out of the cache, then you can pin it. And so if your company or whatever is like really reliant on this one particular version of a function, then that you can pin it and maybe provide the storage that makes it available.
Yeah, and so that part to me was one of the more interesting things. And then on the other, kind of a shared global repository for code, but now that everything is hashed, it allows people to keep the version that they're using, and they won't be screwed with something like leftpad, honestly, right?
Yeah, right.
Yeah. And so I think that it gives you a lot of interesting properties. I think like if it turns out that like a function has a security vulnerability, there would have to be some way of marking that function and its associated hash as being vulnerable and deprecated. But yeah, outside of that, I can see this being pretty exciting because you can work towards a set of functions and concepts that interoperate with each other, especially because like Unison is based on and written in Haskell with type checking. Like I could see them building a repository of functions that work kind of in the same way that you build up a body of knowledge in mathematics, right? Yeah. I think that's what I'm trying to express, because right now for imperative programs, you have this body of libraries and programs, and so maybe you have 1 or 2 winners, but like it doesn't feel like a body of knowledge because like it doesn't necessarily transfer. Like the knowledge from one doesn't really transfer. But like if you have types with pure functions, then that sort of stuff seems to transfer in the concepts transfer in the same way that mathematical functions are the same no matter where they are.
I see. So basically you're saying that what the sort of stability of these functions and their sort of global availability it gives you is the idea that just like maybe string reverse is a sort of fundamental concept that is available in a standard library. You can have your sort of standard library go beyond just manipulating primitive types, but also include larger patterns.
Yeah, because sometimes I wonder why we don't have a global test suite for things that we might use often. I mean, in this, for example, like I know that I guess people building CSS engines, I think like whatever the foundation that like does CSS has a suite available for people to like test their code against, but I want that for like all different concepts. Like if you are writing a Markov chain or something like that, then you can just run against these standardized tests for it, and then you feel like you're good to go after you pass all the tests, right? If you want to write a new version. And so you might have a different implementation because, you know, it's faster, it's or whatever, optimized for a particular like platform or something. But yeah, like something like that, because it just, we have a problem with software just being huge and it doesn't work. Did you see on Hacker News today where like the Air Force was like, what was it, like fix our computers? That was the hashtag, like fix our computers. Stop buying like planes and tanks and stuff. Just fix our computers, because like they're sitting around, like it takes them literally an hour. I thought they were joking, but like an hour to log in to something to check their email on Outlook for whatever reason. Jesus. I don't know why.
Yeah.
But like we do have like a software problem where like our code bases are just gigantic and still nothing works. And so I think a lot of it is just we build fast and we build with concepts that teeter at scale. And like you said earlier, like it gets to scale quicker than we anticipate. And you're not going to need it. So we find ourselves there. And
I think that having this giant shared repository of functions and thinking about, you know, all functions ever written as part of the universe of functions that you can use is really powerful. And
at least that's a dream, right?
That's the dream. Yeah. I know that like Unison has a sort of Unison cloud that they're working on. Yeah. I imagine that Unison cloud is going to look something like this giant global computer that we're thinking of. But I think the details are pretty sparse. I haven't seen too much about it. Yeah, actually, so like I was thinking about it as a giant repository, because the flip side of things is having a pool of computers that you can use to compute, right? Yeah. Because that's the flip side of things, because with Unison, I imagine that a good business model for this is they just run a fleet of blank computers and you can just ship functions to them to run. And operationally, I imagine it would be really simple for them to do that too. Yeah, I mean, I think that's the dream, right? Like this is what everybody's working towards. And even, you know, the programming environment, Dino recently like started a similar version of like a Dino cloud, and I think it's sort of based on the similar insight that in a Dino program you can import packages just by URL, and in fact that's the only way to import packages. And so a Dino program has no, you know, dependency or package management. And so you write your Dino program and you can ship it to this Dino cloud and it will download all the packages and inflate them into a program and run it. And so, Unison, again, like takes that even further and says, you know, there are no packages, there are only functions. And if we have a giant, global repository of functions, then we'll provide you just compute. And this compute knows how to run every Unison function ever, provided that it's been uploaded to the repo. Yeah, and I wonder if there's no way they haven't thought about this, but like one step beyond that is if anybody can run a node and then get sent compute functions and you just run it. But like, I'm not sure exactly how that would work, because you'd have to trust people to run your actual function, because if Unison Cloud is running it, then you can be reasonably sure that they'll run it. But I guess that's like a blockchain question, honestly, because it's kind of like that. Yeah. I guess, exactly. Well, so what about zero knowledge proofs? I'm just like talking out of my ass here. Yeah. But like if you could have somebody run a function, like if I sent you a function to run and then you provide me proof that you ran it without showing me the exact steps of the computation, I mean, that effectively would be a cloud in which I don't have to have a single service running it. It could be anybody. Yeah, I honestly don't know enough about I don't either. This thing either. But no, I think, like I said, I'm talking out of my ass. So no, I think I've seen a few blockchain projects that are trying to do this. Like there's one called like Internet Computer, that's literally called. Yeah, they went up and went back down. I'm not sure. Are they legit? Are they a scam? I don't know. I read some white papers. No. All I know is I noticed them. The price went up and then they went down, and I have no idea where they're at. Yeah, I mean, presumably they have some, method of certifying that, the function that you sent to them is the function that the whatever node ran, and so I'm sure that there are ways to get some amount of guarantee, and so but I agree. I think let's wave our hands wildly and say this is mathematically possible. That would be super cool. Is if anybody can provide compute, and Unison Cloud is not just one cloud provider. It's this whole
federated
federated thing. Exactly.
That would be interesting, and that would be a threat to like the cloud compute giants today, I think, if it actually works. But I don't know, maybe we'll leave that there before we, because we don't know anything about it. We haven't done any research on that. I'm just talking out my
exactly. Actually, I do wonder one more wildly speculative thing, or I guess this whole podcast is
this whole podcast is like two guys drinking and talking out of like just speculating on stuff.
So I wonder how much of this content addressable concept is dependent on the implementation of the Unison language itself. Because if you could decouple this idea of content addressable functions from languages, then you could do this using, WASM or something. And so you can have, write in any language, the sort of WASM linker or whatever does this content addressability. And so then you can have this, like, basically what we're talking about, this Unison Cloud, a whole universe of every function ever. But they can also just be written in any language ever, as long as they can compile to WASM. So it presumably could work. I mean, I don't know if there are other things that this content addressability relies on, like some other key aspect of the implementation of the Unison language. If not, you could presumably just hash anything, right? You can hash this like the WASM opcodes or whatever, and that's your content addressability.
It might I wonder what the details are, because then if there's like compiler optimizations, that might change the hash, but maybe you just hash it in the abstract part so that like you won't get these different platform specific dependencies that might change the hash. So maybe. And actually, the company I work at uses a build system called Bazel. But the interesting thing about Bazel, as well as I think Facebook has their own variant of this, is that they have what are called hermetic builds, meaning that when it builds a package, it does not take into account, or it doesn't read from the external environment, and so you have reproducible builds. And so I think reproducible builds are something that's really important to many open source projects and things like that. And so I imagine if you combine reproducible builds with content addressability, you might be able to get a lot of the same benefits. When you talk about reproducible builds, I was thinking about it also in terms of for the long term, because say in 10, 15 years and you have like older machines and you want to build that software again with immutable functions, you should be able to do that again. Given somebody pins it or something like that. But because a lot of the old software nowadays, you can't even like rebuild it. People are like, I can't rebuild this thing.
Yeah, actually, not even just old software. Like if you find something that's interesting on GitHub or whatever, and it's written in C, like half the time, not half the time, like 75% of the time, you clone the repo and then you like run the build.sh or whatever, compile.sh, and it's like, I don't have this thing, I don't have that thing. Right. This thing only like works on this like one version of Arch Linux that like this grad student like was running when he wrote this. Yeah. And so like it's just such a pain, right? Like you really can't rebuild software. It's getting better, right? Like as we go into more, higher level languages, you don't run into that low level of compilation issue. But honestly, if you've done any amount of work in Python, Python has this whole idea of like virtual envs, because
the Python environment is such a mess. Like it's so much of a mess that there's an XACD on it.
Yeah, exactly. We should put that in the show notes. No, but honestly, it's crazy, right? Like if you just want to like run a Jupyter notebook or something, you have to, and you have the slightly wrong version of Jupyter and the slightly wrong version of Pandas, and like your friend sends you a file or you clone it, like you just can't run it. And so Python's solution to this was, this whole thing is so fucked up. What we're going to do is allow people to create these like little sandbox environments where you don't rely on anything being reproducible, and instead you just build everything from scratch again, every single project that you want to run.
Yeah, but that's given that those servers are up too, right, to download those packages. And so being content addressable, you could conceivably throw it on a distributed content storage like IPFS, and as long as somebody pins that history, like you can access it when you want to get nostalgic and rebuild stuff on old computers that you have lying around. And that's not inconceivable because computers aren't getting that much faster nowadays. It's not like the 90s where like people kept upgrading computers every 6 months. Like I interned at SGI Silicon Graphics before, and they make like supercomputers there. And for a time there, they joked that in order to design new chips, you have to use the computers that you have today to simulate what those new chips would do. But because computers get so fast so quickly, you could just wait and do nothing for a couple of months for the new computers to come in, and you would complete your simulation faster than if you tried to do it from the beginning. That's how fast things were improving back then, the hardware. And so, I mean, like that doesn't happen anymore. And I have a MacBook Pro from 2011 that is still perfectly fine. I use for minor things, and it's perfectly usable.
Yeah, I know. I think that preserving the
sorry to cap that off. It's perfectly usable given that the software is available to use it. I mean, Apple has cut me off and says we're not going to support this software-wise. And so you'll have to rely on older versions of the OS. And so for some of the brew packages that I have to install now, like I have to now start installing them from scratch. And so that's where you would run into like the C sort of stuff. But for, as an aside, Rust packages are pretty good because you just run cargo build and it'll build. But yeah, I mean, like it's not out of the norm outside of like nostalgic reasons to want to build software for old computers.
Yeah, totally. I think that we're keeping our hardware around for longer, but also like just in terms of historicness, like we've said on this podcast, like computer science is like ahistoric or whatever, like it doesn't know its own history, and like I think like we just like have so many packages, so much software being written or that was written in the past that like honestly like nobody can do anything about anymore, and so it's kind of a shame, right? Like we should be able to like go back into our history and say this was how this software was, and actually be able to like run it.
Yeah, and the only people that are motivated to like redo that stuff are people that are nostalgic about the games that they played in middle school, right?
Yeah,
so that you get more emulators of like consoles than you do of like various systems. I mean, the Amiga, I think, or Commodore 64 or the Amiga, people are really excited about those, but outside of that, nothing. So anyways, so taking it back to Unison, and I guess we were like, oh, how does this like thing about Unison help, these other things? Did you have other things to say about its potential? Because I see like, what is this, the hot reload server?
Yeah, I mean, I actually don't know too much about how Unison works at runtime, because a lot of their documentation discusses how it works at compile time. But I think it would be cool if you have this idea that you can update functions without having to update like all of the code base that depends on it. If you have a running server, you say, I have a new version of this function, I've uploaded it now, and now all of the other functions point to this new one, and then you can sort of hot patch your server without having to sort of take it all down.
Yeah, it's kind of like how you can do this today with Erlang and Elixir, but outside of those languages, I've not seen anybody else be able to do stuff like that.
Yeah, and I think that Erlang and Elixir work a little differently, because when you do a hot code reload, you're actually updating the sort of the binary instruction set. You're not updating the AST.
Oh, okay. I see.
But anyway, I think it'd be cool to just have another language outside of Erlang and Elixir where you could do this.
Right. Yeah.
You can actually do this in Lisp. I remember hearing that like the Hacker News server, PG would just like connect to it, connect a REPL to it, and just like write code into it. So I guess you could do it with Lisp, but it sounds really risky.
I don't know, but the thing is, I mean, we talked about it in small talk briefly, but like if you have visibility and you can run REPL and you can inspect your program while it's running, that's also pretty powerful. Yeah, I mean, like I don't know how many times I've had the case where it works on my local machine, but then like it's not in production. I have no visibility into like why that's happening, and so now we have this whole cottage industry that's sprung up around the term of observability, so that we have all sorts of metrics on that. And I mean, it's in some ways it's nice, but like if you have observability into what your production system is doing, maybe the best kind of debugging is live debugging. So I don't know.
Yeah, no, I think it'd be cool. I mean, I'm not opposed to live debugging. I think the reason why connecting a REPL to a Lisp server and like typing code into it sounds risky to me is because it doesn't have the nice thing about Unison, which is that you can sort of roll back to a different version and things like that. So, if you screw it up, you have a typo in your REPL, then you have to frantically type back the original version of the function.
Yeah, you broke the universe that you're in. I guess it'd be even worse if you broke the connection too, so you couldn't type anything in.
Yeah, exactly.
All right, so yeah, I mean, I think that we've covered a bunch of ground on Unison. I am pretty optimistic about these guys, and so like, how can they get there? I don't know. Do more talks and get more people to use it and look at it, I guess.
Yeah, I think that these are really, really powerful concepts, and actually, I think that what I would encourage, the Unison developers to do is to actually see if this can be applied outside of just this one language. Like I'm sure they want people to use this language, and I'm sure that it's a great, very fertile like testing ground for these new ideas because they can test without being constrained by all of the sort of existing baggage that software engineering has. But once they've come upon some really core concepts, I think that the world deserves to use these without having to all switch to a completely different language. And so I hope that one day we can sort of translate this outside of just this one language.
Yeah, but you know how developers are. We're just so slow to change our tools.
Yeah.
Despite working in technology, you think technology is like a fast-paced industry. It's fast-paced, except for the tools that programmers like to use. Like you have to wait for the old programmers to die before like people start like, I mean like you've heard the anecdote about when compilers first were written. People were like, "That's such a waste. Why would you do that?
Right.
Assembly is all you need."
I mean, I think there are alternatives to this, and so one thing that convinces people really quickly is when they realize they can do things that they thought were really, really hard with a lot less resources than they thought they needed. And so when WhatsApp got built and people found out that they were like a team of like 10 people and they were serving, whatever millions of concurrent connections or whatever using like Erlang servers, then like people were like, oh, Erlang is cool, and maybe like we should build our distributed systems on this because like WhatsApp got bought for $1 billion and there were only 10 people. And so
go finish your thought.
Well, yeah, so I was saying like, that's for if you're building distributed systems or concurrent systems, but like what if some company starts to use Unison and they show everybody like, hey, actually we were able to do things with 10 people that you thought you needed a company of 1,000 people because you didn't need to employ all these people to just like maintain and clean up after the everybody else, right? And so if there's a case study that is like programming with Unison solves all of the hard things that you were previously employing tons of people to do, then like people were probably going to take it more seriously.
So step one, get a successful startup to use Unison before they built any code. Step two, get it sold for $1 billion. Step three, tell people about it, and then Unison will take off. Okay, good.
Yes, exactly. That's the playbook.
Exactly. But yeah, I think we well know that you and I are probably more on the edge. I mean, that's why we have this podcast. So I think if there are good ideas here, we'll either use Unison or like pick stuff from it and hope to find other new technologies that have these concepts built in. So with that, I guess I'm pretty optimistic about these sort of good ideas being diffuse out into the programming ecosystem, but I think it'll probably take a couple of years. How about you?
Yeah, I think that this kind of idea will take a long time to percolate. Well, not a long time. Yeah, I think on the order of a couple of years. But I think that if this can be framed again in economic terms, societal terms, rather than just pure technical terms, I can see this taking off, definitely.
Right. We just have to wait for those old programmers to die.
Exactly.
Well, that might include us, so I don't know. But yeah, so that's it for me. I'm pretty optimistic, and sounds like you are too. So I guess that's it for this week. So I hope you enjoyed this episode, and that you'll be tuning in next week for a new topic with new drinks and I don't know, whatever else.
Yeah, and fingers crossed, by the time this episode goes out, maybe somebody will have bought our NFT. We don't know. We don't know at the time of recording, but if somebody did, go you.
Right. Check out our NFT episode. The link for the NFT is in the description and show notes below. And as always, like us, subscribe, hit the bell, whatever, and we will see you next week on the Technium.
See ya.
Later. Bye-bye.